Hi, Mike here. Right, we're going to find a root to a cubic using Newton Raphson method. So the equation x cubed minus 2x squared plus 2x minus 5 equals 0 has one root. Show that the root r lies between 2 and 3. On the second part, taking r equals 2 as the first approximation, use Newton Raphson method to find the value of r correct to 2 decimal places. And here's the solution. Right, so f of 2, that's putting 2 into the original equation. So I've got 2 cubed, replacing x with 2 cubed minus 2 times 2 squared plus 2 times 2 minus 5, and that gives you an answer of minus 1. F of 3, putting 3 into the equation, we get plus 10. So we can see that f of some value would equal 0 somewhere between x is 2 and x is 3. So that proves that 2 less than r less than 3, r lies between 2 and 3. And from looking at those figures, it's probably nearer the 2 than 3. Second part, Newton Raphson, that's the formula, states that xn plus 1 equals xn minus f of xn divided by f dashed xn. So that means once you've found one root, x1 for example, then the second root, x2, will be derived by putting x1 into that formula. So we've written down the function again, f of x equals x cubed minus 2x squared and so on. F dashed x, so that's f dashed x or fx differentiated is what that stands for. So we're differentiating x cubed to 3x squared, and the minus 2x squared becomes minus 4x, the plus 2x becomes plus 2, and differentiating the minus 5 just disappears. So taking x1 equal to 2, you find that x2 equals x1, which is 2, minus f of x1, or f of 2, divided by f dashed of 2. So putting the values in of 2 into the fx equation and f dashed x equation, you get that 2 minus 1 divided by 3 times 2 squared minus 4 times 2 plus 2, which is 2 and a sixth, or 2.17. So now you just keep repeating that process, but taking the value you got from before, so x2 is 2.17, and you can then calculate x3. So x3 in terms of x2 is x2 minus fx2 divided by f dashed x2. Won't repeat all those, but you can see exactly what I'm doing, just putting 2.17 into that equation, and you end up with 2.15. And repeating that process to get x4 in terms of x3, we then get x4 equal to 2.15 minus just a little bit, which actually doesn't change the 2.15. So the process has converged on this value, and the answer to 2 decimal places is therefore 2.15. And that's the solution. Bye for now.